just to make sure for those people who are not here, we'll record this so they can be part of it. So we've got from 1940, we had 440 who were abstaining from alcohol. And then from the recent survey, you had 396. So that's what you are going to be doing here. Change that to 440 for the first one. And then for the second sample, the recent survey, we would change that to 396. And then your sample proportion that they are talking about is basically where you are doing this calculation, which is taking the x1 value, dividing it by n1, which is giving us 0.4. And then the second one is giving us 0.036. And if you look at how I designed these, just click on that cell and you will see this is where we're taking the x1 value, dividing it by n1. Same thing for that second sample statistic. You will see again, we're taking our x2 value, dividing it by n2. So that's how you are calculating your P1 and P2 statistic values over here. So that's the number you are going to put in here. So this guy was 0.400. They want us to put it to 3 decimal places. This guy was 0.360. So check your answer. And that's kind of where having these kind of spreadsheets really makes it easier for you, because once you do the original setup, then as you change these numbers, it automatically will do the calculation for you. Now, the second part of this question actually asks you to check and see if you're meeting the requirements for a normal distribution or not. So remember, there are 3 requirements that you have to check. One of them, of course, is what we are doing over here, where we are saying you have to multiply these 3 quantities together and make sure it's going to be greater than 10. And you do that for sample 1 and sample 2. So we want to verify that these numbers will be greater than 10. Of course, we also want to make sure our sample size is going to be less than 5% of the population size. And for the most part, that's an assumption we are willing to make, because, if we are talking about the population of United States, we know we have more than 1,100 people in the entire population. So we can definitely say, yes, our sample size is going to be less than 5% of the population size. So that one we can safely make an assumption. Looking at the 2 samples between 1940 and the recent survey, there's no reason for us to believe that our data is connected, right? We have no reason to believe the people were the same or any of that. So we can safely say our samples are going to be independent. And then the last one, of course, is that check we do to make sure when we multiply these 3 quantities, they are coming out to be larger than 10. So again, you can see the way we calculated this. We took our N1 value, we multiplied it by P1, which was this 0.04 that we calculated, and then you multiply it by 1 minus the P1, which is what we're doing exactly. And you can see that number came out to be 264. Definitely larger than 10. Same thing for the second sample. Again, we took our N2 value, multiplied it by P2, which was the 0.3600 number, and then the 1 minus P2. And of course, you can see this guy is also coming out to be larger than 10. That's 253.44. So you are meeting all those requirements, and we can go ahead and check this and say, okay, that looks good. And now here is where we are getting into the hypotheses testing. So for the hypotheses testing, we need to see basically how do we need to set up our original, the null and the alternative hypotheses. So the question they're asking you in the example is, oh, there we go. I couldn't find it. Here is the question. They are asking you, has the proportion of adults who totally abstain from alcohol changed, and then they're giving you the level of significance as 0.01. So based on the idea that they want to know, has the proportion of adults, the number of people who stay away from alcohol, has that changed? Can you tell me what kind of symbol you're going to use here for the null and the alternative hypotheses? Do we do equal to, less than, greater than, not equal to? How are you going to set up your null and your alternative hypotheses?
Equal to.
Very nice. For the null hypotheses, we set it up as equal to. And then for the alternate one?
The difference.
The not equal to?
Yes, not equal to sign.
Yeah, because they're not asking you if it has increased. They are not asking you if it has decreased. The key word is, has it changed? So they don't care if it has increased or decreased. They just want to know, has it changed? And that's why you will be using the not equal to. So you really do have to look at your question to try and decide, how you're going to set up that alternative hypotheses. So of course, once you get those symbols in, go ahead and check your answer. And now you can see they're asking us to find the test statistic over here. So the test statistic is that, calculation that I have over here, which is this number over here. So what I did actually was used the textbook formula just to show you how, you would use the built-in, the formula from the textbook. So one of the first calculations that you have to do for this is actually, we found out the p-hat-1 and the p-hat-2 values, but this calculation is actually just based on p-hat, which is using both of our samples, sample 1 and sample 2. So you can see this is the formula for just the p-hat value, which comes from taking the sum of our x1 and x2. So you will see that is in parentheses over here. So we're taking the sum of x1 plus x2 on the numerator, and then we're dividing it by the sum of n1 plus n2 on the denominator. So that gives you your p-hat value. And we are going to need that, over here in the denominator. So that's why we needed to calculate this number. And then here, of course, you're using p-hat-1, p-hat-2, which are these numbers over here. And then, of course, on the bottom, you also have this little guy. So if you look at this formula here, it's basically following that same thing. So this one over here is your p-hat-1 minus p-hat-2, which will be these two numbers. And then on the denominator, we are taking square root of this guy here. So this is coming from, this number, the p-hat, and then the 1 minus p-hat. And then these guys over here is the second square root, and that's the second square root here, which is using 1 divided by n1 plus 1 divided by n2. So all of these formulas have already been set up in here. You literally, all you have to do is just change these numbers over here. And, if the sample size changes, you will change that. But if the sample size stays at 1100, then you don't even need to change those numbers. And you're just changing the x1, x2, and it automatically does all the calculation for you. So this was using the spreadsheet. But if you wanted to use StatCrunch, then this is where, let's bring this guy over. Okay. So let's change these numbers from our example. So the first one, we had 440 out of 1100. And then the second one was 396 out of 1100. And then, of course, we need to set up our hypotheses testing. So this will be the equal to, and this would be the not equal to. And the difference here is the way they write it in my stat lab compared to how they write it over here. So in my stat lab, you will see we are writing this as P1 equal P2, but if you do just a little bit of equation solving and subtract that P2, move it to the other side, this ends up becoming P1 minus P2 equals 0, which is what you have over here. And then with the not equal to, that simply changes to the not equal to, and you end up getting P1 minus P2 not equal to. 0. So honestly, all you need to make sure is that you have the right symbol over here. And I believe that's all we need to do, because we're not doing a confidence interval. We are doing a hypothesis testing. So that's the first option. And then all you will do is say compute. And that should give you your answers. So of course you should verify your sample for 1940 and the recent one, and then you can see all the other calculations that it's giving you. Now, if you compare the answer you get for your z-stat, which is our test statistic value, you should see similar answers between what we had. Let me see if I can move this around a little. There we go. So look at the number we got from using the formula from the textbook, and look at the number you have here from using the built-in StatCrunch function. So that's why especially for chapters 9, 10, 11, if you guys are comfortable, I would say work with StatCrunch, because it does make those calculations go a lot faster. So just copy that number over from the StatCrunch calculation, and you're just bringing that here for your test statistic. And we're only rounding this to 2 decimal places, so that should be 1.93. And you should be good to go. Now, this is kind of where the Google Sheet I created stops, because you will notice that I do not have the p-value calculation in here, because that is actually a little bit more complicated to do it by hand. And so for the p-value, I definitely think having the StatCrunch makes it a lot easier, because you can see it already calculates that for us. And you just have to copy it over from here and paste it. And they want us to round this to 3 decimal places, so that should be 0.053. And you should be good to go. Now they just want to make sense of, okay, so what is that p-value really telling us? What can we say about the data over here? Has our number of people from 1940 to the recent survey, has that number changed? Are more or less people abstaining from drinking alcohol? So this is where they gave you that level of significance. This is where you have to do the comparison between the level of significance, which is our alpha at 0.01, and then you compare your p-value to that, and our p-value of course is 0.053. So do you guys remember this from the last chapter, what the comparison is for us to accept or reject the null hypotheses? What's the comparison between the level of significance and the p-value? Deandra?
So if the p-value is less than the alpha, then reject the hypothesis.
Very nice. Yes. So if the p-value is less than your level of significance, you reject the null hypothesis, because that means your percentage has changed significantly. So what would we say about the comparison between 0.053 and 0.01? Is this less than, greater than? What would you use in there?
It's greater than, p-value is greater than alpha.
Yeah, because you've got 1 in the second position and you've got a 5 over here. So this is greater than. So since it's not less than, you cannot reject the p-value. So what option do we go with here? Equal or not equal?
I don't know. That's why I was getting confused yesterday on those.
Okay. So the question is, if the population proportions are, let's say, equal for now, one would expect the sample difference proportion, and I may have to clear this out. One would expect the sample difference proportion to be either greater than the greater than the absolute value of, smaller than the absolute value of. So I don't know, let's just pick one option for now. And this is where you kind of have to use the information given to you in the p-value. So you can see they're talking about, okay, if you are observing out of 100 repetitions, you know, how many are changing? Well, look at the first two decimal places, because, you know, that is going to be, the first two is going to be out of, you know, the 100. So that means you are looking at 5 out of 100. So, you know, we would be saying, okay, so you've got about 5 out of 100 repetitions. So the question is, if your two population proportions are equal, and this is, you know, between the 1910 and the recent survey, would we expect our sample proportion to be greater than the absolute value of, smaller than, or smaller than the absolute value of? So which one would you choose if you are observing 5 out of 100 repetitions of this experiment? Because when you did the comparison between your p-value and alpha, we had greater than, right? Your p-value was greater than. So honestly, you're choosing between, is it going to be greater than or greater than the absolute value of? Those are the two options you really want to think about.
So it'd be greater than the absolute value, right?
Yeah, that's what I would go, because you just never know with, you know, these kind of numbers, what it can come out to be. So I would always choose the greater than absolute value of. And then, of course, we are not rejecting the null hypotheses. Yeah, Ali, very nice. So out of the not rejecting, which option are you going for? Do we
So
have, sorry, go ahead.
You do not reject because there's not sufficient evidence.
Right, because your p-value was greater than your alpha, since we have 0.053, alpha was just 0.01. So yeah, the idea is, do we say there is sufficient evidence or there is not sufficient evidence? And Riandra, did you say not sufficient or sufficient? Sorry.
Not sufficient.
Not
Do not
sufficient.
reject because there's not sufficient, right?
Well, I was kind of thinking we should have sufficient evidence, because that's a good difference between the alpha and the p-value.
Hold on, let me go back to my notes.
And, you know, if you kind of think about just in terms of the basic numbers, you did have 440 back in 1940, and it's dropped down to 396 also. So, you know, even if we just look at in terms of those numbers, but obviously from our hypothesis testing here also, I would want to say sufficient evidence, but, you know, sometimes I think one way and then I'm, you know, not in the right sometimes. So let's see, if the p-value is less than alpha, we reject. And this guy is greater than, so we are not rejecting. So you are choosing between do not reject. And then the idea is, do you have sufficient or not sufficient? Well, let's check and see what happens if we did part D, which says there is not sufficient evidence. See, now that's where I always make a mistake, apparently. Because I want to say there is sufficient evidence, but obviously they are saying, no, there is not sufficient evidence.
Yeah, it's confusing. Going back, so where did you find, or how did you figure out where it says if the population proportions are equal, not equal to, where did you get equal? I guess because I got the calculations right, but when it gets to this, like these questions, I get confused.
So in this case, it really did come down to trial and error, Deandra, because I've tried it both ways. But normally I look at it as because they kept the sample size the same. I kind of always go with, you know, if they're keeping the sample size the same, then your population proportions, because you're trying to expand this study basically to the entire population, right? You want to say we can apply this to the entire population and say, you know, has basically how much alcohol people are consuming, has that changed over the years or not? And so that's kind of one of the reasons I went with equal, is as long as those sample sizes stay the same. But it definitely does come down to trial and error, because when I was first, you know, picking these examples and solving them, I would try it both ways just to make sure I was on the right track or not.
Yeah, so I do that too, like with the homework. If I'm unsure like that, I'll do the trial and error thing. But then when it comes down to, of course, like the exams and stuff, you could only
Yeah, so
select
for
one if
this
you don't
one,
know.
the equal is kind of what we are going for. Yeah.
Okay.
So basically, that's kind of what I wanted to show you guys, was how, you know, once you kind of figure out how to use StatCrunch, it really is not that hard. So I would recommend, as you guys are working through these examples, to look through that. Another thing I wanted to point out was, if you go under the textbook page, and I'm just going under the textbook for this particular section, but, you know, of course, it's going to be there for the other sections as well. If you go towards the end of the section, they actually have a technology help section, which kind of shows you the step-by-step instructions. And of course, you will see even in some of the examples, they break it down, but this is kind of where you will see at the end, they of course give you instructions for Excel and then some other technology, but this is where I would say you can find the instructions for the StatCrunch. And you're literally just following those steps and it'll make it easier. And you can see when we did StatCrunch, it literally was just putting those 4 numbers in, you know, making sure we had the right you know, hypotheses set out. Come on, buddy. So just putting those 4 numbers in for the 2 samples we had initially, and then making sure if you're doing hypothesis testing, this is set up correctly. If you were doing confidence interval, then of course you would select that and make sure you have the right level of confidence in there. So either way, you know, are you doing hypothesis testing or confidence intervals, these calculations work out very, very easily. And I definitely recommend you guys to practice a little bit with StatCrunch, because it will make a lot of your calculations go by, you know, faster, which will also take, you know, some of the stress away of trying to do the calculations based out of the textbook formulas. But that's, you know, still available to you if you wanted to use it, because that's kind of how I've designed these spreadsheets over here. So please look at the examples, guys. It will make your life easier. Under the view section, again, you have the examples for chapter 4, section 4.1, 4.2. And this is a different example than the one we just did right now in class. This is 11.1.11 basically. So that's the example that I have in here. And the one we worked on is 11.1.19. So you got to see, you know, just a little bit of a different example, just so you can kind of do a comparison between those two. Any other thoughts? Okay, so before I let you go, again, email me, let me know which exam you want to retake, and I will set that up for you. And then I will be seeing you guys for the in-class version of the final exam next week on Wednesday. And don't forget to request your password for the chapters 11 and 4 exam also for this week, guys. Okay. All right. So Ali, definitely please stay back and I'll answer your questions. Deandra, Jose, any other questions coming to mind, guys?
So I've been working with StatCrunch, and I've been doing a little bit better from chapter 9 on, but I know I like totally bombed chapter 7 and 8 exam. So I don't know, I guess at that time I wasn't familiar with StatCrunch, so I don't know if there's a time where maybe you and I can Zoom or whatever, so I can ask questions specifically on that, because I do want to take that exam over again, but I just
Okay.
don't know exactly how to navigate through StatCrunch for that particular section.
You know, honestly, we can take a look at it, Deandra, but I have not used StatCrunch on chapter 7 and 8. It's only with chapters 10 and 11 that I've actually used StatCrunch. So, but if you want to go over and kind of figure out by reading instructions and seeing what's going on, I can definitely help you with that. But I personally don't have StatCrunch experience in those 2 chapters. But yeah, we can definitely look at it if that's something you want to explore with me.
Okay. I'll just, I
Um,
guess, shoot you an email and
So I definitely have office hours this afternoon. I don't know if that time works for you or not, but if it does not work, then send me some times and we can figure out when to meet.
okay, sounds good. Thank you.
Yeah, you're welcome. Anything else, guys? Jose?